All right, so for this assignment, we are supposed to kind of show our process about how we propose a structure, given the molecular formula and determine the saturation level, and giving different graphs on the spectra, IR, 13C NMR, and the 1H NMR spectrum. I have my completed worksheets right here, just so you guys can see. But I felt like it would be a lot easier to kind of walk you through a blank one as quickly as I possibly can to let you know how we do it. So the first thing here that we do, it's kind of my lesson plan. First thing here that we do is that I determine the saturation level. So we know that saturation is 2 carbon plus 2. 2, that's kind of like half. So I have half, 12 minus 8 equals 2. This lets me know kind of for the future what my proposed structure could possibly look like. It's going to have 2 rings or 2 pi bonds or 1 pi bond, 1 ring. Keep that in mind because at the end when we're building the structure, that's going to be very important. Once I figure that out, I go back to my graphs and I start with the IR graph. Here is pretty straightforward. I look at where I see certain peaks at. This peak is 3,300, Cm minus 1. This one's at 3,000, Cm minus 1. This is at about 1,700, Cm minus 1. And this is at about 1,300, Cm minus 1. I then go fill that out in this group, in this table, 3,300 Cm minus 1. That's the frequency that we see certain things at. This is 3,000, 1,700, 1,300, Cm minus 1, Cm minus 1, Cm minus 1. This is my favorite one, the IR graph, to interpret because it's pretty straightforward. I feel like once you look at it and once you get used to it, it's easy to recognize the functional groups and the bonds and everything like that to help you propose a structure. So I know from the last worksheet, you look at this right here. Anytime you see a broad circular one past 3,000 frequency, it's going to be the OH functional group, and it's broad. There's a table and we were given pretty much a breakdown of what the different frequencies and what the functional groups would be depending on that frequency. So I've kind of memorized the main ones. So I know that 3,000 is going to be CH. I know that 1,700 is going to be, I believe it's C double bond O, and 1,300 is CH again. It's odd because sometimes there's an overlap in what you'll see in one frequency, another frequency. This is going to be very important for the end of our graph and the end in what we propose the structure. I then move on to the next table, which is the 13C NMR. The process for this is similar, but it's a little different because we're looking at ppm now. So again, we start by labeling the peaks, and 3 peaks tells me that my proposed structure is going to be heavily symmetric. Once I make that determination, I know most pp ranges up to 40 ppm is CH2. So I know up until here, all of these are CH2, which are methyl groups. So again, it's kind of just picking out the numbers. I know that this is 20. I know that this is 34. And I'm going to estimate this to be 178 ppm, ppm, ppm. Now, again, remember I said based off of the 3 peaks, I know that it's heavily symmetrical. And based off of these, I know that these 2 things have to be a methyl group because of they're up to 40. So let's go to the graph and we fill that out. So we have 20, we have 34, then we have 178. So 20, because it's so far I'll show you the graph again because it's so far close to 0. I know that it is going to be CH2, which is a methyl group, but we have to bond it to something. So we're going to bond it to C double bond O because we know oxygen has to be present in order to get some type of symmetry in this. Then at 34, I know that that's a single methyl group because we're closer to just the 40. So we dash there. And then for 178, based off of a worksheet, not a worksheet, based off of a kind of like a list of things we were given from a previous assignment, I know that this is COOH. For my last graph, probably one of my least favorite to interpret just because it's so much to interpret here, as you can see. Luckily, the integration was given to us on this. So the integration 4H, 2H, that's very important for when we're building the proposed structure. So I know this is 4H, and I'm gonna put 2H way down here just to give us some room to interpret. The multiplicities are important. And so yeah, we're on the 1H scale. Once we determine the multiplicities for the scale, which isn't hard because kind of look at the table, the 4H, 1, 2, 3. This is triplet. This is pentate. And again, this is going to be important for the determination. But we're going to look at the chemical shift now. This appears to shift based off of the graph right here at 1.90, and 4H further down is about 2.43, maybe 2.5. From that, we're able to interpret the structure. And basically, I kind of combine these two along with what I know with 4H triplet. So I have for this one, CH2, CH2, another CH2. I know it's 3 CH2s because this is a triplet. And I know it has to be CH2 methyl because of my previous graphs up here. So I kind of combine this CH2. And I know one of my CH2s have to have a carbon, or one of my methyl groups, I should say, have to have a carbon connected to an oxygen on it. So do that twice. Pentate. And I know this is just let me know CH2, CH2, CH2. So if you don't know anything else, you know that methyl has to be very prominent in this structure. Now that we have all of this together, I now can propose a structure. How I propose my structures, based off of just the repetition and everything, is just putting everything together. Again, this makes it easy. The interpretation of the 1H NMR and the chemical shift 2.43 makes it a lot easier because I already have my base. So I know that I have to have carbon, 3 methyl groups, another carbon, but I'm missing something because up here I know I have 4 oxygens and 8 hydrogens. And here I only have 6 oxygens, or 6 hydrogens and no oxygens. So how do we fix that? We add an OH on one side and an HO on the other side. This is looking more, just to give you guys a view, this is looking more like the structure that we're supposed to have. But I'm still missing my bonds, my double bonds. I know that there has to be double bonds, and I know I'm missing oxygen. So, missing 2 oxygens because I have 2 right here, and it's 4 in total here. So I double bond that to the carbon, and I double bond that to the carbon. Everything for my molecular formula, unfortunately my recording stopped, but I'll piece them together. So, this is my final proposed structure. Everything is accounted for from my 3 methyls because I know it's triplet. I have 1, 2, 3, 4 oxygens. I know that from up here. I have 8 hydrogens, 2, 4, 6, 7, 8. Everything's accounted for, so this is my proposed structure. That's kind of how I use these graphs to interpret and propose a structure. Thank you, and I hope that this was helpful.